We wanted to do question 12 on page 174, so I'm going to do it right now. There it is. It says work out angle X given your reasons for your answer. Well, it's supposed to be rather difficult. It's so extremely easy. It's question 12 with a squiggly fuzzy purple question mark, like it's all rack your brain. It's really easy. It's boringly easy. Now look at this one here. I've got angle AOB. The exterior angle AOB is going to be 290 degrees, and that makes the interior angle AOB, guess what, 360, take away the 290 degrees, which is 70 degrees. Isn't that lovely? Now look, I've got a chord going from A to B, straight across there like that, and I've got the angle at the circumference is now 70 degrees, and I have the angle at the center is 70 degrees, and the angle at the circumference will be half the size. So therefore X is going to be half of 70, and that's all there is to it. 35 degrees. So easy. Very disappointing. Anyway, this video is really about the assess, so off I go. We're now in the assess, and I'm not touching any of the grade B stuff. I've done so much of it in the other vids. I'm jumping straight into this question here, which is the last of the B's, top range grade B, and then I'll do some grade A questions, and that's it. Now this is in fact question 4. Blah de blah de blah, circle, centre, quadrilateral, etc. Work out the other two angles, and don't forget to show you're working. Alright, it's not cyclic, so I can't say that and that adds up to 180 and that adds up to 180. I'm really stuck. So what am I going to do here? Now I've got a rule to rescue me. I'm going to draw a line from P to the circumference and from the circumference back to R, because look, I've now created a mystery chord P to R with an angle at the center and an angle at the circumference coming from the same chord in the same segment. So if that's 150, this is going to be 75 degrees, okay, half the size. If that's 75 degrees, I've created a cyclic quadrilateral, so angle 75 and angle PQR add up to 180, so this must be 105 degrees. Isn't that lovely? Alright, 105 degrees, because 75 and 105 is 180. The angles are supplementary, that's it. And now I've done the hard bit. Now the easy bit. This is an angle. It is, and it's part of this quadrilateral here, PQRO, and therefore I simply have to go 360, take away the 150, take away the 105, take away the 55, and we'll get angle R. Okay, so angle, let's call it ORQ. A little hat there. It's going to be that. Let's just grab the machine quickly now. So 360, take off the 150, take off the 105, take off the 55, leaves me with 50 degrees, and that's the end of it. Beautiful. Grade A? Yeah, well, no, not really. Let's just turn over, see what we get. Right, 4 questions. This is question 5. Claimed to be grade A. Well, it is. Look, 33. Tangent. This segment is here. This is the alternate segment. All of this part here, and that's the alternate segment theorem applied. Angle A is 33 degrees. Alternate segment theorem. What about here? Angle B, exactly the same. That's a 58. There's a segment here. This one right there, and this larger one is the alternate segment, and therefore we have an angle formed with the tangents and this chord here, and this is the alternate angle within the alternate segment, therefore that's also 58 degrees. Now C looks horribly complicated. Not difficult. Look, there's your 44, there's your chord, there's your 44 made with this chord FG and the tangent, and this is in the alternate segment, therefore C is also 44 degrees. By the same token, look very carefully, that's 78 just there, and in the alternate segment over here we have also an angle of 78 degrees, and that goes with angle D. I've got a triangle now. I can add up these two angles, 78 and 44, and find the remainder from 180 to get E. Or look, I've got angles on a straight line. I can say 180, take away 44, take away 78. Whichever way I do it, I get the correct answer. So let's just do that. So 180, take off 44, take off 78, and that gives me 58 degrees. And that will be the same answer I get had I gone 180, take away these two angles here. So it proves in a way that the alternate segment theory in fact does work. It's brilliant. Now what about D? Right, lots and lots going on here. I've got a tangent to a chord. That's good. Tangent. Tangent to the circle. I'm touching this point J here. I've got an isosceles triangle. All I've got to go on is alternate segment theorem. So here's my 75. If that's 75, then F is also 75 degrees because it's the angle in the alternate segment. And now look, I'm told this is isosceles, therefore G is also 75 degrees. What have I got so far? I've got 75 times 2, which is 150, I'm sure, yes. So if that's 150 degrees, the G and the F combined, the remaining 30 degrees has got to belong to H, hasn't it? And that was really, really easy. Let's just turn over. Right, what's all this about? This is question 6. Let's have a look at that one. Blah-de-blah-de-blah, tangent, touching, etc. What have I got to do? Calculate angle QAB. So QAB. I want that one. Okay then, I can do that. That's the angle at the centre. There's your common chord, AB, forming an angle at the centre of 102 and forming an angle of half of 102 at the circumference. Well, that's going to be 51 degrees. Now, how does that help me get that one? Well, we did a similar question in a previous video, and I proved that actually this angle here and this angle here are the same due to the alternate segment theorem. So straight away angle QAB is 51. And why is that? Alternate segment theorem. Alright, look at it carefully. There we go. Here is a chord AB, here is a tangent making an angle 51 in this segment here. But in the alternate segment, the larger one on this side, I also have an angle which is identical to the angle formed outside there, and they're both 51. Therefore, I've calculated QAB as 51 degrees, and that's all there is to it. Dead easy. What about this one? This is question 7, grade A rated. Tangent to the circle, there it is, that on there, PA, touching right there. PB is a straight line passing straight through the centre O, so that's a diameter. Incidentally, if that is a diameter, then this has got to be 90 degrees, so let me just put that in because it could be useful. So diameter, a triangle touching the circumference in this segment here, therefore that's 90 degrees. Calculate angle CBA. Okay, CBA. Let's just do this. Very straightforward. Look at this straight away. I've got an angle there being formed by this tangent up against this chord, and this is also 35 degrees. It's an alternate segment theorem application again. So 35 there and 35 in this triangle as well in the opposite side. So that's that one. Let's just write it here, 35 degrees. There's that one done. Right, give my reasons. Again, alternate segment theorem rather for that one. Just write it there. That's that one sorted. Next one, angle CPA. CPA. Oh, that's miles away. It's not very difficult. If that's 90 and that's 35, this is going to be 55 degrees. All adds up to 180. So you could write down angles in a triangle add up to 180 degrees and just leave the 55 sitting there. Alright, there it is, 55 degrees. 80, 90 is good. If that's 55, then the angle outside here, which is angle ACP, is going to be 180 because its angle's on a straight line. Take away the 55 and that's going to give us 125 degrees. Easy peasy. And how would you qualify that? Well, angles on a straight line equals 180 degrees, and just leave the 125 sitting inside there. So let's just write it in there. What have I got? I've now got a really pointy little triangle, really sharp and nasty. It's triangle PCA. Well, I've got 125 degrees there, 35 degrees there. I'm now going to work this angle out. So that's 180. Take away the 125. Take away that little 35 there as well. and that's going to give me, just do it quickly, 180, take off the 125, take off the 35, that leaves me with 20 degrees. It looks nice and pointy and acute, doesn't it? That's correct, there it is. So this is 20 degrees, angles in a triangle, and up to 180, etc, etc. So again, don't mess up your exam paper like I've just done. By all means fill in the angles, but do the calculation on the dotted lines, and if you need to use words like alternate segment theorem as to why you just plonked a 35 there, and angles in a triangle adding up to 180 as to why you plonked the 55 there, do give an explanation just to chew the calculation along, and that's pretty good. Time for one more, I think. This is the last question, and it's A star, and I'm getting quite scared, but anyway, here we go. XY is a tangent. Please note I drew that myself because the original Y's come off the page. All these lines are the same, so I've got isosceles triangle there. ABC is isosceles, look, 2 lines, and triangle ACD is also isosceles, line there and a line there. Now that's the storyline, that's X. Calculate, leaving your answer in terms of X, for angle BCA. So BCA is that one. Well, I'll tell you what, that's alternate segment theorem. So if that is X, that is also X. Fair enough? Tangent called X in this segment. This is the alternate segment. There is your value, there's your triangle with an angle X there. By the way, this is also going to be X. Why is that? Isosceles triangle, and the X drawn in as shown there and there form the base angles. So there you go. BCA is X. Now angle ABC, ABC, that one. Well, what's that going to be? It's going to be 180 degrees. Take away that X, take away that X. So take away 2 X's. Okay, straightforward. So ABC is 180, take away 2 X's. Why is that? Angles in a triangle add up to 180 degrees. I'm now told that angle ADC is 102. I think I'll draw it in. ADC is 102. That is 102 degrees. Now it says find the value of X. Well, that's really, really simple. And I'll tell you why that's simple. Because I know this angle is 180, take away 2x. And I know that here I have a cyclic quadrilateral, ABCD, cyclic quadrilateral. Therefore I know that this angle plus this angle adds up to 180. So I'm going to form a simple little equation and solve to find x. Okay, so 180 minus 2x plus 102, plus 102 all comes to 180 degrees. Lovely. So straight away cancel the 180s. I'm left with minus 2x plus 102 equals nothing at all. A bit like taking the 180 over there and subtracting, but I didn't do that. Well, I did do it, but I just subtracted it in my brain and just eliminated my 180s. Sorry. Take away the minus 2x next door. 102 equals 2x's. So a single x is going to be 102 divided by 2. So x is 51 degrees. Okay, very, very easy, I thought, for A star, but anyway, you might have found it tricky. I mean, I particularly like these circle theorem questions. And that is the end of the assess. That's the end of circle theorems. That is chapter 11 done, and I'll see you in chapter 12. Your job, as I keep saying, is to study. Look at these videos for goodness sake. I'm working really hard. It's all for you. See you later.